welcome back to another installment of biology video talks from Mr. Rocher's class. Today we're going to talk briefly about what is science. So I hope you're all ready to join me and find out what exactly science is. First of all, we're going to be really literal because I like wordplay. So science literally means to know. All right, so here are three statements about science. Science is knowledge gained through experience. So for instance, I like birds a lot, and the first time I went birding, I did not know anything. I had to take a book with me. But over time, I gained knowledge of the birds and was able to identify them by their song and by what they look like without having a field guide with me. So science is knowledge that's gained through experience. Another definition of science is an accumulated body of knowledge of the physical or material world through observation or experimentation. This is probably the definition you're most familiar with. In school, you get a lab from a teacher, you go through and you perform a bunch of experiments and observations, and at the end you come out with a result. So we're going to be doing a lot of this kind of science in class. The last definition of science is facts or principles gained by systematic study. So for instance, things like the law of gravity. So those things are all definitions of science. Now, in order to do science, we have to make a couple of assumptions. If we don't make these assumptions, we can't do science. So we have to assume that there is order to the universe. If there's order to the universe, logically, the human mind, it is capable or should be capable of comprehending this order. Okay, so if we can assume that yes, there is an order to the universe and everything is set up in a certain way, hopefully as human beings we should be able to explore and then thoroughly understand that order. The last thing we have to assume is that if conditions are the same, the results of any study will be the same. This is a way you could tell a good scientific experiment, is its repeatability. If you can take an experiment from a scientist and you can duplicate that experiment in your lab, you should probably get the same results that scientist got. If you don't get the same results, either something is wrong with your experiment or something is wrong with their experiment. So scientists have to test each other, and this is really important in science. Because if you have a scientist who's, I don't know, claiming a miracle cure for cancer, and other researchers go and do their experiment and don't come up with the same results, then you have a problem. So it's important to double check your work. All right, so I'm going to pretend that I'm a student here, and I'm going to ask the following question. Which of the following statements can be tested scientifically? So again, we have to assume that there is order, that we can go and use our tools like rulers and flasks. We can use all of our lab equipment like microscopes, and we can understand these questions. So which of the following can be answered scientifically? Let's take a look. This statement says, most of the energy coming from the sun is in the form of visible light. Well, can I test that? I can't go to the sun to see what kind of light is there, but I could use a spectrometer, and that spectrometer could tell me what kind of light we're getting from the sun. Are we getting UV rays? Are we getting visible rays? Are we getting microwave rays? So yes, that hypothesis can be tested scientifically. Shakespeare wrote great plays. Well, I have no doubt that Shakespeare wrote great plays, but I can't test that scientifically. There's no way to measure what makes a play great. Because we all have different opinions. And I might think Shakespeare is great, but you might hate Shakespeare and not be able to understand it. So that cannot be tested scientifically. The next one says the Earth is about 4 billion years old. This one might seem a little tricky, but it is actually possible to measure how old something is. Scientists can use things like radioactive dating and radiometric dating, and this actually tells us how long these elements have been around. So yeah, we can actually tell from carbon dating and other forms of radioactive dating that the Earth is about 4 billion years old. Incredible. All right, the next one says unicorns are real. Now this is very interesting because a while ago, a group of scientists said that they were going to go out and look for an animal they thought was extinct called the ivory-billed woodpecker. Someone down in Louisiana or thereabouts thought they saw this woodpecker in one of the swamps. Now this is a remote place and there's not really much access to it. So the scientists went down there looking for this woodpecker they thought was extinct. They didn't find it, of course, but there's a lot of conjecture as to whether that bird is out there or if someone just made a mistake and misidentified it. So this is quite an interesting question because I can't necessarily prove that unicorns aren't real. Just because no one's seen one doesn't mean they're real, right? They're not real, right? But of course, in science, if I can't prove something is real, then it's not something I can prove scientifically. The next one says, diamonds are more beautiful than rubies. Again, this is another opinion question. I can't measure how beautiful something is. There's no standard scale for beauty out there. And if there were, that would be fantastic, but again, it's something that's based on opinion. So I cannot actually scientifically prove that diamonds are more beautiful than rubies. The last one says, diamonds are harder than steel. Now this one's pretty easy. There's the Mohs scale of hardness, and you can actually do a scratch test where you scratch the object. So you scratch a diamond with something else like a penny or a piece of steel, and if the steel gets scratched, then the diamond is harder. If the diamond gets scratched, the steel is harder. So we can actually prove that that is the case. Lastly, when you're in my class, I'm going to be looking for you to develop some of the traits that good scientists have. And good scientists, there are a lot of them out there, but there are also some bad scientists who take funding and do bad things with it. They have, experiments that aren't proven or are very shaky. So here are some of the traits that good scientists have, and these are the traits I want you to develop in my class. First of all, curiosity. Curiosity is a great thing. I know that you've been in school a long time and maybe you're bored of science already, and science is boring, but I really want you to try to exhibit some curiosity about the things that we're learning, because I think curiosity is the most important thing you can have as a scientist. If you're not curious about knowing what's out there and why, what makes what, then science isn't going to do much for you. Honesty is another important trait for scientists to have. If you can't be honest about the experiment you're performing, the data you collected, or what that data means, then you can end up misleading people. So honesty is really important in my class. An open mind is also important in this class. Some points we might get to material that maybe it's hard to believe, or maybe you're just not sure about it, but I'm asking all of you to keep an open mind and just try to think about this in a scientific way. Another really important quality scientists have is a willingness to be wrong and to make mistakes. Yes, science isn't perfect. Scientists are not perfect. They do make mistakes, and they can be wrong. So it's important when you're doing your experiments in the lab, if you end up getting an answer that makes absolutely no sense, it's okay. Even the best scientists make mistakes occasionally. And what we'll do is we'll be able to figure out together what went wrong and what you can do to fix it. You should also, as a good scientist, ask good questions. So you want to ask things instead of, what is this, or what does it do? You want to ask things like, why is it the way it is? Or how does it get like this? Or how can I change it? So asking good questions is important. And the last thing is having a healthy dose of skepticism about the things you're learning. We're learning new things all the time, and our knowledge is changing day by day. Skepticism is good because if a result seems too good to be true, it might be. Again, in the case of finding a cure for cancer, that might be something that it seems really simple, but if other scientists go look into it, they have to approach it with some skepticism so that they don't get themselves too worked up. We'll talk more about that later. So I hope that you guys learned a little bit about science, and the next thing we'll talk about is the scientific method. Hope to see you all next time. Bye.